Hi, welcome. In this video, we're going to talk about architecture. And I have been working on this Landoss game for a couple days. And as I'm new to Lures, it started a bit slow. And at the beginning, it was a little bit chaotic and a bit slow. So I have worked on it a little bit more and clean things up, and now I get a much better idea. And so without further ado, let's get into it. So when before I start talk about the architecture that I have, and let me just describe what the situation is. So first of all, I am more at work. I'm more of an enterprise application developer. So I look at the code, even I'm writing game, I look at the code more like an enterprise application. So some of the, I understand that, in game development, sometimes the architecture can be a little bit different, and you have to think about the time limit, each frame, how much work you can able to do, and have a very good control over that. So what I'm going to talk about is not related to in that direction, and is more related to the overall architecture of the application. How do you organize dependencies? How do you organize the code? Because to me, to have a good application or good game, and that no matter what kind of application is, that is critical. And for one thing is, I'm working on this, I work on this game for for my own education and learning, and also try to create something. And as mentioned at the beginning, Lua is a complete new language to me, and that is also one of the reasons I'm doing this this game, so that I can learn the system. So what I'm going to say is my own personal experience and my own personal take on it, although it is backed by a lot of general practices. So first of all, let's take a look at the code. Okay, so first is about the organization of the project. So one of the things that when we talk about architecture, you take a look at the top level, and what I learned is a lot of the things I learned is from Uncle Bob, Robert C. Martin, and the idea is, what you see here is about sometimes people call it screaming architecture, and to me is also related to clean architecture. And essentially is that when you look at your file, how you organize your code, it should screaming at you what kind of things that you're working on. So for example, you see that this is there's a game folder, some game data, there's a gateway, I'm going into that a little bit, there's the scenes, and then widgets and spec, and then so inside the game, say for example here, what you see is actual classes, or essentially I should say files of idea about the game. And the same thing for gateway. Gateway essentially is a generic term meaning some kind of gateway to access some external resources. So the resources could include, like say, getting some game data in this case, and also getting safe data. So game data are the data that for the game to say the image or the static, say when your character levels, you know, how much experience is required. In this game is about a card game, you know, what kind of cards are there. And so those are game data, while safe data, of course, is safe data, right? And then for the scenes, that's the UI scenes. About, you can think of it as pages, like the word scenes is used in Solo 2D, right? That's how it organized the pages. And then widgets, it's just widgets. So that's how I organize the game at a high level, at a file and folder level. So then let's go into take a look at the actual code, right? So say, for example, this game, well, it doesn't have any much things in it, and or say over here there's a skill file or skill module. And the way I organize it, you know, besides based on the idea of the application that you're working on, is also that when you're writing a module or writing, you know, when you're writing code, you fall into essentially 3 different paradigms. You are either writing structural or procedural programming, you're writing OO, or you're writing functional. Right, you can mix and match about that, but you know, generally, you know, those are the 3 kinds of paradigms to fit into. And for me, OO is really nowadays, you know, I've been doing programming for many years. OO is not about modeling the real world, and it is more about managing dependencies. And in that sense, is actually, if you think about it that way, the OO and functional, you know, it start to merge together. You start to see there is actually not much difference between functional programming and OO. Of course, functional programming has a pretty different paradigm, and it have monads, monoids, and talk about lazy evaluation and all that stuff. But for the sake of this video, we're not talking about that. We're just talking about the concept of using function as a first-class entity in your program to organize code, right? So as I said, OO is really about dependencies, about managing dependencies. So say you have a class, say for example over here, let's use the class game as an example. It's a little bit easier. So in a game, a lot of time you think about game as an object, right? Game as an entity that it contains some states, and then you act on it. Well, yes, that is true, but the question to ask is that well, methods in a class is act on a particular set of states, right? In OO is the state inside the class, but the question is, does it have to be inside, right? So what you see is you can actually, if you separate the state and the function, then you can get to what is called data-oriented design. So then you have some data, and then you have a bunch of functions that can work on that kind of data. And so then if in OO you think about they are grouping together, and then the state is contained within. And in functional, you can still, you know, just pass that state into a function, process it, and return a new state. Or if you forget about the immutability, and then you can just change the state, right? Although, you know, when you talk about functional programming, you don't really need to do that. And it is it is actually better for you if you're not making changes to states, right? And then another thing is that when you're creating a class, is you're managing dependencies, right? So in a class, say for example over here, it's need to say for this function, let's assume this is a method for a class. So the method is say does it have save data? Then if you are writing in the class paradigm, then the class need to get hold of the repository, or in this case it called gateway, to where I can ask, okay, is there a save file, right? Is there a save file over here? Or if there's a save file, I can assume that there are save data, assuming the save file doesn't get corrupted, right? And so it need to get information from somewhere, and that's better not embedded within the class itself, because if not, you will have a tight coupling between your business logic, which is this game, and the data access logic, which is accessing on the file system, or it could be accessing to the server, or it can be accessing somewhere else, right? So having this separation is important, and that's where architecture comes in. So when I'm writing code, no matter it's game or at work or doing an open source project, I always have that separate. And then that is if you're interested in learning more, is you can search for clean architecture, and just Google it and look at that, look at some articles about it. It's pretty easy to find, and you will understand what I'm talking about. So the gateway thing is really external, it's an adapter to external dependencies, right? And those external dependencies are something that you want to have a strong decoupling, a strong shield from those external dependencies, so that your code can be testable, right? So that it can be modularized, can be separated, and you can and it can be quote unquote reused. But personally, in my own opinion, reusing game logic is not very often, or basic business logic it doesn't happen a lot. In this case it will, because as mentioned, the reason I'm doing this is for the for education purpose and for my own experience purpose, right? So once I'm done with this game, I might port some of the logic to another language on a different game, right? So in that case, some of the logics can be reusable, or at least the idea can be reusable. So able to separate the concern from the get-go have a strong benefit, right? To me, besides just able to test, able to change things around, right? And then if I get into that, this video will never end. I can talk hours and hours about it. So back to here. So as you can see, the way I'm organizing it is passing in the context, and then the context is containing the dependencies. Okay, so you can see I am going for a more functional approach than OO, as I mentioned. I used to do OO at the beginning when I would just start writing program, because that's what you learn in school, right? And then also when I start working, I work on the OO language, and so things are in OO. But I always feel that there's something wrong about OO, and so here is I'm going away from it, and the context is essentially containing the dependencies. And then if it needs additional data, say for example over here, then the state, or it depends on what it is. It could be states or could be input. It will goes into the function. So So over here, I'm not using Lure's method mechanism. If it was method, then I will declare this as a colon, and then I can do, say, a function game new, and then do an n, and then local o equals to a object, and then set metadata metatable o, and then self, because I look at it a couple times, so now this become a little bit more easier to me. So o, actually o dot under or index equals self, and then return o, something like that, and then you can say b equals to game new, and then g has save data, and then call it, and then inside there you can access the self. Right? But I don't really find I need to do that. But one thing is the state is, to me, is always transparent, and I don't need to protect it because that is just how I write the code. I know by principle that I shouldn't make change to it, or if I make change, is a specific, very specific thing that I do that I know what's going to happen, and then the data just pass around. So the benefit is that I can freely add things, add quote-unquote methods to the object, to the state, and do various things, and then I do not have to bound or create things like a fed classes that have multiple concerns. Because one of the things, say for example, you maybe you have heard about solid principles, and the first one is SRP and the single responsibility principle. And in single responsibility principles, the thing, how this is defined is there should be only one actors to a particular class or particular code that would cause a change, right? So if I'm doing it functional style, I have some data, and then I have a file that contains a bunch of functions that act up on this data in a particular way, then it easily satisfies the SRP. And if I have another actor and another reason I need to change the state, I can just put it in another file, right? So it frees yourself from how to organize the code, and also at the same time minimize the changes or the potential of stepping on other people's work, right? Because SRP, one of the benefits is that you just, if you work in a team, a particular file or particular module is managed or changed by one or a few people, and then other people can work on other things, and then you have a less chance to mix work and cause problems, right? So that's one of the benefits. But I'll stop. I'll cut short here, because as I said, if not, this video will never end. So so that's why I'm doing this. So I fully aware that I might not be utilizing all the glory of the language, the Lua language itself, because I'm not using class, I'm not using the data driven design, data oriented design, by because even if I'm using the colon, right, Lua, it is the same, very similar, or I should say very similar to Rust, that allows you to define that functions anywhere you want. So you can have a function to the game here, and then you can go somewhere else and then define, say over here in another file, and then say game of doing something else, or adding another function, and you have access to it. So I'm not utilizing that idea, and but that is okay, right? Because so far I don't have that need, but I do utilize the fact that Lua, everything is just tables, right? Even this a module, you know, the file, you can think of it as a module. The module is a object or table, right? So like this game, and that's what we're returning. So it is a table that can be passed directly. So what I'm to functions, what I mean is this. Say for example, I'm just randomly picking one. Hopefully there's something over here. Not this one, but it's close. Let's say over here, yeah, like this. So here I have a game data module, which is under the game folder. You can see I get it over here, and then I get the gateway, the save data gateway and the game data gateway from the gateway, and these are the modules, right? Or actually the table, right? So then what I did is when I'm constructing the context to pass in, I just pass that in directly, right? Because that is a table itself, or in other language, object itself. So I can just pass it in, right? So you don't have to instantiate, you don't have to create an instance and pass it in, you don't have other things, just pass it in and just work, right? That is definitely a benefit, and I do that a lot throughout all the code, right? So that's that. And then another thing is for the context, I am organizing it in a way that is transmissible, or it can be passed around to different logics, or to different logic or functions. What I mean is, say for example here, I have a specific naming convention. So in the context for the game that I pass the game data in, if it needs a game data gateway, I call it game data. Maybe later on I can change it to game data gateway to make it even more explicit. And then if save data, it's just always called save data gateway, always called save data. So inside the code, say for example over here in the initialize function, I don't think I have an example here, but say I can always do that. So I can say this, I can pass in the context there. Say if this new function, this is a little bit old, I haven't worked on this yet, but say I do this, right? Player.update player, and then pass the context in. So in that case, I don't have to do any of that. I can just do this. Right. So the context can pass around to the other functions, and the other functions knows that there is a save data around, and there may be also, if it needs, there's a game data around, and the only requirement is at the top level when I am creating it, I need to aware what are available. And what the tree, the game initialize called the player.update, and I need to know those tree what kind of dependency they need. So that is one of the quote-unquote drawback of dependency injection. And in a lot of frameworks in other language, you use some crazy contraption. You create an XML and define the dependency outside, and it has all kind of problem. That's on that one is called surface locator anti-pattern. So if you're interested, you can check that out. So that's also have its own problem. So but that's just a small price to pay, and also to mitigate that, you nicely organize the your dependency into certain chunks, right? Say for example here, the dependency just save data and the game data, two of them, right? And as long as you manage the dependency to be just a few of them, it's not too hard to manage, right? If you have this, if you spread it out to so many small different things, then that would be a problem, right? So that's also one thing to consider when you organize the code. Yeah, so basically that's it I can think of. Yeah, so also another thing I can add on regarding this context is that I don't have to put in the logic in there. So the logic meaning inside this game folder, right? This I don't have to pass it around because they are all just functions, and they are all the same, just taking content and do things, and they are pure, right? If you know about functional programming, all these functions are pure, meaning they don't contain state. They don't do they mutate is a different thing, because they can mutate through the dependencies, right? Say for example, in this I don't think I have a code right now. Let's say update, right? Just for the sake of it, yeah, for this update, right? It will update the outside world, update the state of the whole world, but it's do it through the dependencies. It do it through the dependencies so that you don't really worry about it, right? So actually this should be game data. I haven't finished up my refactoring. So yeah, so that's why I don't have to pass it around, and I just focus on external dependency, and it keep your context small, right? So another thing I want to touch on is about the testing, right? Okay, again, personally, I focus a lot of testing, and from some of the early videos I show how do I set it up and get the test, and from there you can see right now I have it working and able to run some tests, and have the test folder and doing all that. And the test folder organization is off topic because that depends on the library, the test runner that you use, right? So but one thing is I can say about that is I have some utility functions. Say for example over here in the game level, I have a table utility function just doing some basic stuff. I'm adding a bunch of utility functions, a map, concat, and map accumulate and find, and so on. So all these are really testable, and it's important for me to set up the testing environment so that I can test this, because these will be reused over and over and over again, and we don't want to have bugs in them, right? So that's why having the test is important, and organize it this way I can get the test, get this code and test them. Say like what you see here, I'm testing the table util, map accumulate. The name doesn't really matter. It's just one way to describe it. It can be anything. It can be break it down to smaller code and so on. So yeah. So and then another benefit for doing this, right? Having the functionals and then explicitly passing the context. Well, in this case, in this talking point, whether OO or functional doesn't matter. The important is dependency injection, right? You make sure that all your dependencies, especially for those that touch the outside world meaning say the database, file system, network, or the UI, all those things are passed in if needed. Sometimes passing in the UI is a little bit harder because you have to flip the dependencies and all that. So but in this case, I'm not doing it except, like, say this, right? There's some events, and so I'm inverting the dependencies by providing a event so that the interaction can be captured on the UI side, and I can emit the event from here, right? It's some very basic concepts. So as long as you're able to do that, then all of this code will be able to be tested in unit tests, in writing tests over here. Because when your applications get bigger or your game gets bigger, right, a lot of this, is very hard to test it in the real application because there's so many things going on at the same time. So when you find something's wrong, unless it is a UI glitch, then it could take you a lot of time to find out what happened, right? So that's why organizing the code like this, separating the dependencies so that test is really, really critical. So yeah, so that's about it. That's it for this video. That I've covered everything I wanted to cover, and hope you enjoy this and hope you learn something. And this this architecture talk is not necessarily just to game programming. Obviously, it's for any application. So I wish you understand what I mumbo jumbo, and can make sense out of it. And if you have any question, feel free to ask me question, drop a comment and about it. Hey, I'm not clear on this and that, and drop it in. I will try to help you and answer them. All right. Again, that's the end of this video. So hope you enjoyed it and hope you learned something, and we'll see you next time.